Okay, we're going to go ahead and get started here. My name is Brandon Brown. I'm an additive manufacturing application engineer here at Quest Integration, and thanks for coming to our supply chain coffee breaks. A little bit about me before we get started. I have a bachelor's of science in mechanical engineering from Montana State University. I graduated back in 2017. I have over 20 certifications with Formlabs, Markforged, and SolidWorks. I've been a Quest employee for 4 years, actually almost going on 5 now. 5 in July. And outside of work, I'm an avid mountain biker and skier. So in this webinar series, we've been discussing the supply chain related benefits of additive manufacturing, namely pertaining to the logistical workflow and product related aspects of the supply chain. And today we're going to be focusing on the workflow benefits of additive manufacturing relative to the supply chain. There are a few key areas this pertains to, namely with regards to learning the process, using the equipment, and maintaining the equipment. And additionally, I forgot to mention, if you guys have any questions about any of this, feel free to stick it in the question box in the GoToWebinar interface, and I will answer them at the very end. When it comes to learning manufacturing processes, especially traditional processes, you typically have to learn a couple things, namely the design constraints, how to program, operate, and set up the machines, as well as any associated like fabrication or like any associated like fabrication skills or anything of the sort. With traditional processes, there are several design constraints, as every process has, but with each different process, like the design constraints for a mill and a lathe are going to be different, and for an injection molding process are going to be different than those, et cetera, et cetera. And then learning how to program and operate the machines also takes a significant amount of time. It's no small feat. These can be fairly complicated operations depending on what you're doing. And then same with machine setup. This can be relatively simple or it can be relatively complicated. And then when it comes to learning actual fabrication skills, this is something that takes a lot of time and experience and kind of hands-on time to learn and to actually finish some of these, like to finish out some of these processes that is necessary. In reality, what it comes down to is this is a very specialized knowledge and skill set, and significant education is required. And you only really want to have people go down this route if necessary. Typically, you'd have a few specialized people that know how to do this and deal with this that have been educated. In contrast, additive manufacturing has a lot fewer design constraints, and it's also much faster and easier to program. You only really have to know how to use the slicing software, and these are a little easier to use than, say, a CAM software. They're also pretty universal, so the machine setup is universal. You don't have to set up multiple different types. You don't have to know how to set up multiple different types of geometries or different materials. You simply just kind of set them up once, like say level the bed and make sure that the machine is maintained, for example, and the machine is pretty much good to go. You only have to do that every now and again. And when it comes to actually operating the machine, there's very little in the way of actual operation with 3D printing. You just kind of load the build and hit go, and the machine just kind of does what it needs to do. You don't really need to stand around and watch it if you have a quality 3D printer. This really means that the machine operation can be learned pretty easily. It can be picked up kind of on the fly, or through like kind of help documents or support videos or informational videos. It's a lot less specialized knowledge, and it's really easy to justify learning and easy to pick up. It's not this huge commitment like some other processes are, and you're pretty much any of the staff that already exist at your organization can learn this process. When it comes to actually using the equipment, typically with traditional manufacturing, you have to go to where the equipment is located, which is typically the shop, or you have to go to the people that are going to be using the equipment if you're having a part made. Then you have to build or acquire and install the tools and fixturing that you're going to need for the manufacturing operation that you're performing, whether it's, say, installing and setting up an injection mold or setting up fixturing in a vertical milling machine. Then you have to actually go through the setup process for the equipment after you've installed all that and run the equipment, adjust it as needed, watch it, make sure that it's running properly before you produce more parts. And this often requires multiple people to complete. For example, the engineer, this varies from organization to organization, but the engineer designing the parts is probably not the guy that's going to be going out into the shop and making them. Each job again can take a lot of tweaking and setup, so this really just kind of draws out into a kind of long, complicated, involved process to even make, you know, one or two parts, which is kind of a worst case scenario for some of these processes. So you really don't want to invest in these processes unless it's justified. You don't want to go through all this hassle unless you absolutely have to. And additionally, if these machines are already producing parts, you don't want to stop them and reset them up for another part or production run if possible. And this is kind of where additive comes in. When it comes to using additive equipment, you kind of just go where the printer is. This can be as close as your desk if it's a small enough machine. You set it up if it's not maintained, and if it's regularly maintained and regularly set up, you probably don't even have to set it up. You load the material if the material you need is not already loaded. In many cases it is, and then you hit print. Because of this is a really easy process to learn and kind of get up to speed with and get help with. Again, you can watch videos and read kind of support and like get quick start guides to get up to speed on this stuff relatively easily. You can be in a really easily accessible location, like say an engineering area relative to all squirreled away in the shop. There's very few specialized people required, even if you have a larger, more industrial additive system. Due to the nature of 3D printing and how it works, there's going to be a lot fewer people required for those systems, at least most of them. Because of this, it's really easy to justify the use of 3D printing because there's very low of investment to make something relative to other processes. And it's pretty easily accessible. You're not tying up certain people as nearly as much. You're not tying up other resources. It's really just a lot more nimble and a lot more flexible. And then when it comes to maintaining the equipment, this is the kind of the final area. As you guys know, traditional equipment is typically pretty complicated. If you think about a lathe or a milling machine or an injection molding press, or even a large sheet metal press, they're relatively large, complicated machines. They're also, like say in the case of a CNC machine, they're very, very precise. If you crash a CNC machine, you have to typically have special technicians flown out, or get them on site, or you tie up internal maintenance and repair staff to repair your equipment. Because of this, you don't really want to put wear on these machines and risk damage unless it's absolutely necessary. This ties into everything else, maybe not risk damage, but you don't want to, like say, put a new job in there, set it up, and then accidentally crash it. That would be really, really bad. Just another thing to consider. Additive, on the other hand, these machines are very simple. They're software driven, they're very connected, and they're very smart. And this really means that anyone can kind of work on these machines. So at least at a lower level, for most 3D printers, even some of the more industrial systems, these machines are pretty simple. There's really not a whole lot going on in them. Like with most 3D printers, come down to a simple 3-axis motion system with a few stepper motors and maybe a few tubes. Some are simpler than that, and this really means that you don't have to, at least in a lot of cases, you don't have to call out, if it's a critical issue, you don't have to call out, like say, a support tech from the OEM or a reseller. You can simply look at the support documentation or a tutorial video, and pretty much anyone who can turn an Allen key can work on, say, that X7 right there with those resources. It's pretty straightforward, and this really comes down to the fact, this really leads to the fact that you really don't have to care as much about these processes. It's pretty easy to justify kind of turning these loose to make other parts and keeping your other equipment busy with parts that they absolutely have to make. And in summary, additive equipment and related workflows are, because of these factors, simpler, easier, faster, and therefore cheaper than traditional processes, at least in kind of lower volume area, like lower volume production runs and just kind of general use. However, additive does not replace traditional processes, it simply supplements them. Because of this, you know, like say if you need one-off parts, prototypes, etc., it's a lot easier to justify an additive process instead of, you know, putting a CNC machine that could be generating more value in production and things that have to be CNC'd. Yeah, and it's a lot easier to justify an additive process for parts like that. And you can leave the traditional processes to what they excel at and let additive kind of take up the slack and get the parts that fall between the cracks. That's about all I have for you guys today. We got a few upcoming events. So we have our next supply chain webinar on end product benefits on June 23rd. Make sure not to miss that one. We do offer 3D printing training now if you're interested in that. Email us at info@qintegration.com or call us at 800-370-3750. We'd be happy to get you signed up for that. Additionally, check out the new videos on our YouTube channel. So we have a lot of new videos up, everything from maintenance tutorials for our 3D printers that we deal with here. Everything from that to kind of more fun videos like us trying to break some Markforged parts and useful SolidWorks tips and tricks. Definitely check that out. I think there's something you will definitely enjoy or get out of that if you do. Additionally, if you're interested in 3D printing at all, or if you're interested in learning more about kind of what we do here and how additive could fit into your organization, reach out to us using that contact information and ask for me, Brandon Brown. I'd be happy to talk to you about that. And I'll go ahead and answer questions now if there are any. Doesn't look like there are any questions. So I'm going to go ahead and end this webinar. And thank you guys again for coming. I really appreciate it. And I hope you have a great day.